Hello Tachyons, this is Kumar and welcome to the TachyLab. We are doing motion, forces and energy and this is lecture number 4 of physical quantities and measurement techniques. Today we will be doing some questions. So here is the first question. It says the diagram shows a rectangular metal sheet close to two rulers. What is the area of metal sheet? So area of metal sheet and metal sheet is rectangle. So what is the formula? So formula is length into breadth. And what is the length that we have to measure from here? And see the rulers, both of them are given in centimeter. It starts from 10 and finish at 45. So this value is 35 centimeter. And what about the breadth? It starts from 5 and it goes up to 25. So this is 20 centimeter. So area would be 35 into 20, that is 700 centimeters square. I hope the answer is clear. It is option number A, 700 centimeter square. Now, a student measures the volume of three liquids using three different measuring cylinders. The table shows the volumes recorded by the student. Which readings are recorded correctly? So in the first one, we see it is 0.5, 1, 1.5 and 2. And there are 5 divisions in between. That means each division will be equal to 0.1 centimeter cube. Right, in the second one, we see it is 1, 2, 3, 4. And there are 5 divisions. That means each division will be equal to 0.2 in this case. And if we look at the third diagram, again, it goes from 10, 20, 30, 40. So in this case, each division will be equal to 10. So the first one, it says 0.5, 1, 1.1, 1.2. So yes, measuring cylinder 1 reading is correct. If we look at the second one, it is 2. It will be 2.2. It will be 2.4, not 2.2. So second one is wrong. Then comes third one. So it is 10 and 20 and this is 22, this is 24 and this is 26. Now you see the liquid is neither at 24 nor at 26. It is somewhere in the middle. So we'll say that okay, it is 25. So the third reading is also correct. So first and third measuring cylinders, their readings are correct. So answer is option C. That is 1 and 3 only. Second one is wrong. Moving to the next question. In order to determine the period of a pendulum, a student times one complete swing of a pendulum using an analog stopwatch with the second hand. Which change of method produces the greatest improvement in accuracy? Okay, first is asking a friend with shorter reaction time to take the measurement. Okay, this will improve the accuracy, but not that much. Measuring the time for 100 swings of a pendulum, dividing it by 100. Yes, option B is correct here. It's always preferred to take more readings. That will reduce the error immensely. Then comes measuring the time for half swing of a pendulum and doubling it. No, not at all recommended. It will make the measurements more sensitive instead. And then using a digital timer. So digital timer, okay, that will give you more precise reading. But then what about the reaction time? Okay, so that will be a case. So it is option B, which is correct here. Moving to the next question, which measuring instrument can be used to find the volume of a small stone? Measuring tape, meter rule or protractor. So these cannot be used. Answer is option A, that is measuring cylinder partly filled with water. What you will do, you will take a stone, you will just immerse it in the liquid and you will find out that okay, how much the water or the liquid has, right? I hope this is clear. Okay, now a lump of modeling clay is moved from a small measuring cylinder to large measuring cylinder that has twice the diameter. The reading on small measuring cylinder goes down by 20 centimeter cube. By how much does the reading on large cylinder goes up? So now you'll be confused that okay, it will be 10, 20, 40, 80. Most of the students will go with option A, that is 10 centimeter cube. But answer is B. It will remain same, that is 20 centimeter cube, because they are talking about the volume. 20 centimeter cube here tells us about the volume of the modeling clay, which will not change in whatsoever beaker you're putting it, that will remain same. Yes, the height of the water, that will change, or the liquid, that will change, that will be affected, but not the volume. And here the readings, the value is given centimeter cube, they're talking about the volume, so it will be B, that is 20 centimeter cube, that will remain same. Moving to the next question. A pendulum makes 50 complete swings in 2 minutes 40 seconds. 50 complete swings. What is the time period for one complete swing? So first of all, we'll convert it into seconds. So 2 into 60 plus 40. So 120 plus 40, that is equals to 160 seconds. So this is the time, and number of oscillations is 50. So how do we calculate the time period? So it will be 160 divided by 50. That comes out to be 3.2 seconds. So answer is option number B here. I hope it is clear. It will always be the total time divided by the number of oscillations, that is 50 in this case. Yes, so the next question. Which measuring instrument is used to measure the diameter of a thin metal wire? Now, if we talk about 30 centimeter rule, measuring tape, or meter rule, they all measure the distances, right? A diameter is a kind of distance, right? So they all measure the distances, but large distances, not very small distances, or they are not capable of giving us readings which are more precise. And if we talk about the diameter of a thin metal wire, we need reading which is more precise. So that's why we have Vernier caliper and screw gauge. So vernier caliper is more sensitive than this, and screw gauge is sensitive, is most sensitive one. Right? So option D is the correct here. We will use the micrometer screw gauge to find out the diameter of a thin metal wire. Then a student is taking some measurements. Which measurement is taken directly using a micrometer screw gauge? So if you see here, you don't have any apparatus, diagram, or data given to you, and you will be confused. Is it your focus will be on the values here, the magnitude, but you don't have to focus on those values. The reason being, if you look at the units are different. And since you don't have any data, diagram, or anything to actually tell about the magnitude, so you just ignore it. We know we are talking about the screw gauge here that measures the distance or the length. And length unit is millimeter, centimeter, meter. Correct? And here it is only option number C which is giving us the reading in millimeters. Rest are in area or density or something else, but not the length. If you're liking my way of teaching, do interact with the video and subscribe to the channel. Free notes are available. You can find the link in the description, and you can also contact us for one-to-one and group classes. Moving to the next question now. It says a student places 600-gram masses in a stack as shown. Part A says the height of the stack of masses is 5.4 centimeter, as you can see in the diagram. Calculate the average thickness of one mass. So there are total 6 blocks here, and the height is 5.4. So what we will do, we will just divide it by 6, and it will come out to be 0.9. So answer is 0.9 centimeter. I hope this is clear. Now, part B says the figure shows the masses, a measuring cylinder, and a beaker containing some water. The student uses the equipment in figure to determine the total volume of the 6 masses. Describe a method that the student uses. So what will you do? We will use the measuring cylinder. We will partially fill it up with water, and then we will immerse all of those masses in that water, and then we will see that okay, how much the water rises. So you have put water in measuring cylinder, you take the reading, you put the masses in the measuring cylinder, immerse them completely, and again take the reading. And now if you subtract those two volumes that you just noted down, you will get the volume of the 6 masses. So measure the initial volume, immerse the 6 masses completely, and measure the new volume. And the volume of the masses will be increased in the water volume. So that is V new minus V old, and you get your answer. I hope it's clear. Okay, so next part. Figure shows a coil of wire. A student measures length of the coil using a ruler. His measurement is 3.8 centimeter, and there are 20 turns of wire in the coil. The student uses his measurement to calculate average thickness of the wire. So the wire is like this, but the spacing is not there. So it will be like this, right? That means how we can find out? We will simply have to divide 3.8 with 20, and we get 0.19 centimeter, which is approximately 0.2 centimeter. So the average thickness of wire is 0.2 centimeter. So total length divided by the number of the turns. That is the working. Moving to the next part, it says the student's measurement 3.8 centimeter is inaccurate, and explain or suggest the reason why. It's a 1 mark question. So just write any one of these answers. Any one you can pick. First is parallax error. That means when you're taking the reading, your eye level is just not correct. If you have to take the reading, it has to be here, not here, okay, or anywhere else. Second is wrong starting point. Sometimes the measurement that we're taking, it does not start from the 0 mark. So that can be one issue. Instrument not aligned correctly. Maybe the ruler that you are taking, you're using, that's just not placed well. Then wires not touching or overlapping, or wire is stretched at some point. So these can also be the reasons why the readings are inaccurate. Okay, so next is the volume of the wire is given. And they're saying the mass is also given, and the units are in CGS, is centimeter cube and gram. You don't need to convert because they're also expecting you to answer in the same units. Calculate the density of the metal used for the wire in the coil. What is the formula for density? Density is mass by volume. Density so it would be 148 divided by 16.6. So how much does it come? Let's just calculate. 148 divided by 16.6. So it comes out to be 8.9. It comes out to be 8.9 gram per centimeter cube. Here is the work. Density is mass divided by volume. Mass is given, volume is given. Substitute the values Calculate. I hope all of you got the answers. Okay, now next part. A student has a measuring cylinder and a beaker of water as shown. Describe how the student can determine volume of the coil by using the equipment as shown. So, see the object or the volume of that object. That can be anything. Can be coil or any masses. It can be anything. But the procedure will remain same. That is not changing. You take the water, you pour in measuring cylinder, note down the initial reading, you immerse the coil completely in the measuring cylinder in the water, and then you measure the new reading and then you subtract those two readings, that is the new one and the old one. So the increase in the water level, which is shown in volume, that is the volume of the wire too, right? So you get the answer. I hope this is clear. Moving to the next question here. Okay, here it says we have four students P, Q, R, and S, each attempt to measure the time period of a pendulum. The arrows in figure shows the movements of a pendulum that each student times. So here state the student who has chosen the correct movement for one period of a pendulum. So if you look at the P, so this is only half of the oscillation. It's not full. So this cannot be the correct answer. For Q also, the starting and ending, they are same, but it's not complete. So this is also half. If you look at R, again, it started, but then it did not reach the same point here, right? So this is only 3/4 of the complete oscillation. This is also not the answer. But for S, it started, reached the upper end, moved to the other extreme point and then came back to the initial point. So this is one complete oscillation. Okay, so answer is S. Then B part. Another student uses a stopwatch to measure the time taken for 50 periods of a pendulum. Figure shows the time taken on the stopwatch. Calculate the time for one period of pendulum. Give your answer in three significant figures. So here it is 1 minute and these many seconds. So 1 minute is 60 seconds. So it would be 60 plus 23.37 seconds. So if you add it up, it will come out to be 83.37 seconds. 83.37 seconds. And how do we calculate it? Time period, we just divide it by 50. This value divide by 50. And it comes out to be 1.6674 second. But they are asking us to give answer in three significant figures. So that means what we will do now, see, it is 7, right? So we can round it off to 1.67 seconds. 1.67 second is the answer. Okay, next question. It says the student measures the displacement from its rest position. The displacement is given in centimeter. We have to give it in the millimeters. And 1 centimeter is equals to 10 millimeters. That means 16.5. You can multiply by 10 and you get answer, that is 165 millimeters. Easy question. Okay, so this says a student is taking some measurements. Which measurement is taken directly using screw gauge? Again, no data is given, no diagram is given, nothing, but there are values and options. How will you solve it? How will you tell? Yes, think about it. We just discussed it. We will look at the units. So micrometer screw gauge will give you the length, and length is always given in millimeters, centimeters, meters, and so on. So here the reading option C is correct because the value is given in millimeters. I hope this question is clear to everybody. That was it for today. I hope you actually enjoyed the lesson, and you can also tell me in the comment section. If you want me to cover any other topic, you can let me know in the comment section as well. And thank you so much. I'll see you in the next lesson.